Hello, can you hear me?
Yes.
Hello?
Hello.
Hello, can you hear me?
Yeah, we can get you.
Hello, can you hear me?
Yes.
Okay. And I hope you can also see the screen. You can also see the screen. Okay. Just a disclaimer. This is part of the course that I taught for LACAB. And at this point, I will be using the slides, but you are not. You may use the. I'm going to use the slides, but you may not. You are not allowed to share them or use them somewhere else. I am under NDA, but I want to share this information with you. So I hope nothing bad comes out. We want to share the knowledge. So, but the slides were developed in collaboration. It was developed by two professors. It was developed by Andrew and Dr. John. So I give them all credit, and this we've done on behalf of LACAB and the American Spaces. So we will just use part of these slides because some of them are not relevant to you, and then also we don't want to focus much on theory, but we want to design something and then we will print. Okay. Okay. Okay, so today we want to learn about what 3D printer is all about, what a 3D printer is. And then we are going to look at computer-aided design. We are going to design something. We are going to continue from where we left yesterday. And hopefully everyone today has Fusion 360 working. So can we start? Everyone, can you hear me well? We can start?
Yes, you can start.
Okay. 3D printing is a new technology that has changed or revolutionized how manufacturing actually happens. So it's slightly different, or it's different with the other manufacturing processes. One common one which people know is something like CNC or lathe. For those who have done some classwork on mechanical engineering, or those who have done industrial attachment, you might have come across those. So 3D printing is described to as additive manufacturing, whereby what we mean by that, it works by adding material as opposed to other manufacturing processes which are subtractive, or which works by removing material. So it works by, so we first of all get a 3D object, and the 3D object can be your design of, like, the robot which you want to design, or you want to design medical equipment, or you want to design whatever thing you want to design. You design it using a computer-aided design software like Fusion 360, SolidWorks, Onshape. All those are computer-aided design software. So you design it, and then you send the program. You send a program, or what is called a G-code, to the 3D printer, which is the machine, and then the 3D printer works by placing layer by layer, or it works by making the physical object by successively adding material layer by layer. So if you look at the diagram here, we have the green object in the middle. That is what it has printed, and this part was printed by adding a thin layer of material from the bottom in the first round, and then adding another one continuously, slowly until you get the 3D object. Yeah. Is there any question up to there? Is there any question? Okay, let's continue. So, how big is 3D printing, or what is the market size? So it's worth a lot of money, or economically, it's worth around 200 to 500 billion US dollars annually. So what I just want you to know that it's very useful, and big companies are using it, or big industries are using it out here. It's just unfortunate that maybe locally we have not tapped into this market because of the challenges that we are having economically. But if you go to developed countries, they are using them to make mold, like for example, if you go to Boeing, if you go to Apple, where they're making this iPhone, if you go to Microsoft, they're making the Surface laptops, all these nice things, they're using them to make what is called molds. Then also in the consumer market, it's being used to make consumer electronics, or consumer devices, as well as in product manufacturing and other use cases such as medical, industrial. So just know that it's used a lot in making aeroplanes. If you go to Boeing, or if you go to Airbus, you go to NASA, you'll find they're having 3D printers. Theirs might be different from the ones we are using. Theirs could be metal, but the whole concept is used. I want to ask you a question. Anyone here who has heard of injection molding? Is there anyone here who has heard of injection molding? You can just unmute and tell me, have you heard of injection molding?
Personally, I haven't heard of it.
Okay. So injection molding is, if you go to like the greatest one of the largest plastic manufacturer locally is what is called Ken Poly, or like Kenya Plastics. They are making, if you look at the cups, mugs, jerry cans, basins, all those, you see them with a mark with the logo of Ken Poly. So this is how their machine works. We are going to see how it works. It works by pouring, you pour in some plastic. They come in pellet form, or they come in granule form. They look like, if you've gone grinding of maize, most likely you've seen you up something which looks like a posho mill, where you pour the maize and then the maize is grinded. In this case, instead of grinding, it is molten. I'm going to show you with a nice video, and then the parts are formed in the middle part. So 3D printing and injection molding are very helpful processes. Injection molding is used for mass production. If you want to make 1,000 cups, or 100 bottle tops, 1,000 bottle tops, you go to Coca-Cola, like they're having the plastic bottle tops. If you want to make 1 million of them, then injection molding is the best way to use. But for making a prototype, meaning making the first version, making the proof of concept, it uses 3D printing. So let me show you a video very quick, a short video. It's on YouTube. You can just look for injection molding. It's one of my Can you be able to see this? Can you be able to see? Hello? Can you be able to see my screen?
Yes, you can see.
Yes, you can see.
Hello, everyone. Can you be able to see this?
Yes, we can.
Hello, can you be able to see? Boniface, Ochieng, Ronald?
Yes, you can see it.
Yeah.
You can be able to see?
Yeah, we are able to see it.
Okay. So this is a model of something like a basin or a trough, or, like if you look at those EABL, they are making those cans, those containers for beer or things like that. So this is how they make them. And this is how the injection molding machine works. So first of all, this is how it looks like. So on the right hand side, or where I'm pointing on the right hand side, there is this part which looks like a funnel. This is where you pour plastic. You pour plastic in, and then once you pour the plastic in, they get fed into the middle part by using this screw. There is this screw. As the screw rotates, it ensures that the plastic is uniform so that one side is not too hot, one side is not too cold. It ensures that the temperature is uniform, and also the thickness, the viscosity is also the same. So that's the work of those heating filament. The heating filament melts the plastic from the solid form to this viscous form, and then it is fed to the last part, where you are having what is called a mold. A mold is a template. It's like a template of your design, or a cross section of how your design looks like. If you look inside here, the plastic is fed in, and then once it's fed in, it fills in the space, creating your object, which in this case can be a cup, it can be a basin, it can be whatever plastic part that you want. Then the part cools, and then after cooling, then it is dropped. Yeah. Have you seen that? Have you seen that? It gets cooled and then the part drops. So this part is very rapid, meaning even after a second, you can be able to have even a bottle top, or 10 or so bottle top or cups made. So you just press the plastic in there, it fills in that space, then it is dropped. Okay, everyone, is that okay? Yeah, you can even look at, there is even this. Look at this. This is also, can you be able to see? It's the same process that I'm telling you. You feed it in, and then you're making cups, things like that. So you fill in the plastic, the middle part. Can you be able to see? Guys, can you be able to see?
Yes.
Yeah, so unaona tu after one second umetengeneza, I don't know, like this guy has is making almost 9 at a time. So you see how fast it is. Unaona? Yes? Yeah, so that's how injection molding works, and it can be used to make this blow which you press, like if you are making a glass, kuna glass bottle or plastic bottle, pia kuna hiyo unaziweka hapo. Hii inatumia gas. You put the plastic, alafu it is blown like the way you blow the way you blow balloon, and then the parts are formed. So it's that process. Okay, let's continue. So that is how injection molding is. So as I've told you, and all of you can see, it's a very fast process, and it makes a lot of quantity or a lot of the material at once. Let's continue. Okay, so there is this comparison in terms of number of quantity of material or quantity of products which you can make per unit time and their costing. So this graph is just to show you that, in short, if you are having less than 500 units to make, like you want to make 200 units, then you can use a 3D printer. The cost for a 3D printer is possible. But when you go to 1,000, 1 million, then at that point it becomes so expensive because the 3D printer is expensive. Okay, guys, are we together?
Yeah, we are together.
Okay. I don't know why okay. Then I don't know what's going on with the Zoom when I'm trying to share like that. I don't know what's going on. Anyway, so the next is the various types of 3D printers. I'm going to give you as an assignment. I want you to find out what stereolithography 3D printing. Everyone write them down. Stereolithography 3D printing is, or SLA 3D printing, then binder jet 3D printing, and then selective laser melting 3D printing. So SLA, or you can just write in short, just write it down, SLA. What is SLA 3D printer? What is binder jetting 3D printing? And what is SLM? SLM, selective laser melting 3D printing. Then the last one is FDM. FDM. We will explain it again tomorrow. But just go to YouTube or Google and read, and then we are going to cover them. It's tomorrow, because I want us to draw something or to design something. Sawa. Okay, guys. Is that okay?
Hey.
Yes, tutaendelea from there, but just find out what those 4 types of 3D printers are. Then it will be the discussion for tomorrow as we continue, tomorrow or the next session. I'm repeating again, there are 4 types of printers: SLA or stereolithography. Just write SLA, then binder jetting 3D printing, then selective laser melting or SLM, and FDM. So find out what they are, because we want to continue today. Okay, do you have Fusion?
Yes, we have them.
Yeah, fungueni Fusion. For those who don't have Fusion, you can go to onshape.com, or if your machine is slow or something of that sort, you can go to onshape.com. Then you sign in. So Fusion may end the like mine is like having 9 days. So you need to use it well, as in take good advantage of the time, the free version that they are giving you. Like you can see mine is behaving funnily. They want me to pay something. So mine is misbehaving. All of you can see that. So I want us to use something which is free or which is easy to use, free in terms of we can use it ownership. But the process is the same. Kama uko na fusion, I'll figure out what is wrong, but we can try with fusion. It's the process is the same. Mnaona? Can you be able to see my fusion is misbehaving? Mnaona?
Yes. Yes.
But
Yes.
yes, but you can follow along with fusion. It's this process is going to be the same. Nothing much. So I want us to create something very simple. So create document or create a new, and then I want you to call it. Yeah. So create new document. Call it device. You can call it whichever thing. Lesson. You can call it whatever thing you want to call it. Can you be able to see how many? Can you be able to see?
Yeah.
Yes. So it's the same way we were using Fusion, and the interface is almost the same. So msikuwe na wasiwasi, you are going to learn the same way. If you follow it with Fusion, you follow it with this one, bado itakuwa tu sawa. Okay. So if it is not named, you can name it. Like mine, I'm calling it device. So you just want to make something very simple, and then I take you through how to export it and then print it. Okay, so go up there to sketch, create a new sketch. If you are on Fusion, there is the green part. So sketch, and then you click the plane or where you want to print to, and then it turns into this 2D, whereby you are having all these functions. As I told you, it's very similar to Fusion. So I want you to take a line, alafu you draw the line. Now draw hivyo, use the line to draw a rectangle, just like that. Everyone, are you following? You are following?
Yeah, we are following.
Yeah. So this is where you take the line. You can also take a rectangle. You can take a circle, like you take a circle namna hiyo, then unachora a circle. Then there are other things here which you can do. You can dimension. Dimension is unaipea measurements. So this one is in inches. Since Kenyans, we don't deal with inches, we deal with centimeters. There is a place where you should change this to, there is where you should change the measurements to that is where you're supposed to change the values. Instead of the dimensions should be in centimeters, not inches. Let me see. there is a place where you're supposed to do that. Mm, figure out that I'll if when I get it, I'll tell you. It's somewhere in the settings, uh, in the settings for this. So I'll find out and then I'll tell you. Okay, let's continue. Then yesterday we looked at fillet, and we said fillet is used. So you need to select a plane first where you're drawing. Sketch. Ikikataa wacha. Let me undo. So the meeting will end in 40 minutes, in 10 minutes. So that's why I'm hurrying so that we draw something here before. Kitu kama hiyo. And I'm going to show you how to dimension. So you click on the dimension. It's still reloading. It's okay. So the dimension like here is 0.18. You can even decide to use 1, just like that. You can move it down, or you like you want to dimension hii pia, unakuja hapa, then you put a value. This web one iko na shida. Okay, I wanted to move that like that. So try to so once you do this, we are going to learn all those fillet also. Just a minute. Then there is extrude. The first command is extrude. You click on this on the face, and then you can extrude it, meaning you are increasing the thickness. So if you look at it, you're going to see it's now in 3D. So unai refusha, you are making it thicker. Then you click OK. So instead of that 2D or 2D part that we are having, now we are having a 3D object. Then there is this circle in the middle. We can extrude cut. Extrude cut, so meaning you extrude it but inward. So you extrude it inside. You can decide to put like how much you want, 0.5, 0.45, just like that. And then once you are done, you click OK. It's reloading because I don't know, the internet is not good, but it will always save your work. Then we go to, so here haija extrude, haija cut vizuri. Let's redo it again. You click on the face. You click on the face where you want to draw, like the front face. Then let's draw a circle. And you draw a circle. Are you guys there? Are you guys there?
Yeah, we
Yes.
are.
Okay, good. I don't know why it's... So you draw a circle on top of that face, just like that. Then you click OK. You click the green. Then you come to extrude. So instead of this, so it will tell you extrude up to face. You can extrude to next. You can through all. Unaweza work na hiyo. So you click on this, and then you extrude it coming downwards, meaning it will make a hole when you say it through. It extruded on the wrong direction, so you can undo. Please try it. You should do it on the opposite direction, that it will make a hole through the part. Okay, there's something there. They have got a part where you can edit, and then through all, then you can, they have got through all, blind, they have all these things. Then there is part for remove all. So remove. So when you remove, meaning now, can you guys see? Kuna shimo.
Yeah.
Yes, so that is what I wanted to show you. Then you can do all the fork. You can shell inatoa shimo hapo katikati, like it's creating a hole in between the diagram, like you can be able to see. Umeona? So it's like if you're having a round box and then you shell it, sasa itakuwa na shimo hapo katikati. Then there is also fillet, which is my favorite. So you click on the four corners. Fillet we had looked at yesterday. What fillet does is it smoothens the four corners. Kama hapo. So you use this to rotate. Then you click on this. Can you be able to see? Umeona?
Yes. Yes, tunaona.
Yes. Okay. We can say here on top, we can also go and create a new sketch. Hapa juu. And then instead of we are just now using a rectangle. We are doing a rectangle just like that. Then you click OK. Then you can rotate it the way you want. You can rotate it at an angle like that. Then we have looked at extrude. So you click the faces to extrude is you come and click this arrow, that rectangle we drew. And then the thickness or the depth, you can drag it in just like that. So if you want it to cut, unaweza ifanya ikiwa opposite direction. Okay. Just like that, then you click on the okay. But since haijanini vizuri, there is something which you needed to do. When you click on it, then haijatokea, nimeifanya. There is how you need to, when you are doing that extrude, you need to cut. Sorry. Let me show you.